Today's class we are going to discuss about sampling theorem. The learning objectives of the today's class will be able to state sampling theorem, define band limited signal. You will be able to compute sampling rate. The first thing we are going to see about is what is sampling process. Sampling is the process of converting analog signal into discrete signal. Look at the diagram where input is f of t and the system is analog to digital converter. The analog to digital converter receives two input. One is the signal input f of t and another is the control signal from computer. We'll see about this control signal later. The output is f of nTs, which is a discrete signal. So this can be processed by the computer because it is discrete. The output is given to the computer. So next we'll see where for which we are applying the sampling theorem. So mostly it is a band limited signals. So hence, what is a band limited signal? The band limited signal is the one which has zero component outside certain frequency. Look at the figure here. Up to 0 to B you have a component. After B we don't have a component, and such kind of a signal is called a band limited signal. Sampling theorem is applied to the band limited signal. What it states: if band limited signal can be exactly reconstructed if it is sampled at a rate at least twice the maximum frequency component in it. Example, at fs should be greater than or equal to fm, where fm is the maximum signal frequency. Okay, we'll do one problem. So given signal x of t is equal to sine 2 into 20 pi t plus cos 2 into 50 pi t. You know, sine signals are described with the equation sine 2 pi ft. Hence the first signal has the frequency 20 Hz and the second signal has the frequency 50 Hz. So what is the maximum frequency content in it? 50 Hz. So fm equal to 50 Hz. So according to the theorem, fs should be greater than or equal to fm. Hence the maximum frequency, the sampling frequency is 100 Hz. The sampling rate will be 1 by 100. So after sampling and before sampling, how the spectrum? The before sampling, it is a spectrum of the signal, and that we as discussed, it is a band limited spectrum. It extends from B to minus B. So how it becomes after sampling? So you get a multiple replica of the basic spectrum, and there can be gap in between the multiple copy, or there will not be any gap, or one over the other. So when that happens, so when fs is very much greater than 2 times fm, you get a gap between the two copies. You have a gap between two copies. If fs is less than 2 times fm, which is a critical frequency, then you don't have the gap. Instead, the one copy is colliding with the other. That is called aliasing. What is the effect of this aliasing? This aliasing will have the effect on output audio quality because the higher order frequencies are aliased with the lower order frequency. So this is about the sampling theorem, which is used to convert the analog signal into digital signal for digital processing. So we look at the sampled data signal, how it will be. The first one shows the analog signal. The next one is a set of impulses which is given as a second input to the A to D converter. And the third one is after sampling we get a discrete signal, that is we get signal at discrete instance of time. So when the samples at the discrete instance of time after sampling, the number of samples will increase if fs is becoming more. If it is less, you will get a less number of samples. There are less number of samples, it is easy for storage. If there are more number of samples, the storage is difficult and also the processing is difficult. So then has to be an optimum sampling rate, again which should be greater than 2 times f1. Thank you.